let's get started. So one question that came up is late homework. How's that work? When I walk out of the classroom, then the class, and I don't have the paper with me, it's late. If you want to turn it in tomorrow, you can turn it in under my office door. Or on Thursday, you can turn it in class. And you lose 5% per day that it's late. And once I turn back the assignments and talk about the assignments, then we are done accepting late assignments. Well, my goal is to grade this assignment tomorrow. Talk about it on Thursday. If that happens, it'll be the only time it happens this semester that it gets graded that fast. And the stack is only that thick, right? Any other questions? So the question is, what percentage of this assignment does it count towards your grade? 1%. Oh, no. Then we'd need, we would need 50 assignments. And I'm not sure who would die first, me or you. Now, the reason I do that is this assignment I use for various purposes. And, I keep on assuming that, I keep on thinking that students will look back on previous lectures, right? So I give this course and say, oh, here's what I was looking for, right? But it doesn't seem to happen very often. So I'm pretty ruthless in grading this assignment. And the second assignment is usually, okay, now redo this assignment using various patterns. And part of the problem is that when you go through school, eventually you get trained to, well, there's a metric, right? And it's a grade. And we all know that effort, right, moves towards the metric, right? Metrics drive your effort. And since you're students, then grades drive your effort, right? And the problem is that's not a very accurate metric for training programmers to become programmers, right? Just getting grades, particularly when you're in a class this big. I mean, it's like you're not going to get much one-on-one time with someone when there's 60 people in the class. You're not going to get much feedback on your programming, right? And usually I tell students, well, universities are not a good place to become a good programmer, because to become a good programmer, you need practice, and you not just practice, but you need that feedback. And how do you get good feedback on what you're doing? Well, I believe there's now 59 of you and 1 of me, right? And it's not like you're going to be able to build large systems in this class, right? Because you don't have the time. Because it's only one of possibly 3 courses you're taking, and some of you are working, right? So even at 1/3 time, right? It's especially it's 3 months long, and if you're not working and you're taking 3 courses, then basically you've got a month's worth of work that you can dedicate towards a class. And some of that time is spent reading and trying to understand the material. And let's say, I don't know, a third of your time is spent doing that, right? So now you've got 2/3 of a month that you can write code. And how much time is that? Compared to industry, how big a system can you build one person working 2/3 of a month? Nothing, right? And the problem, of course, that 2/3 is spread over 3 months, right? And interspersed with other activities. So it's not like you could just spend that concentrated. I start Monday and I get to work all Monday and Tuesday, right? It's no, you get to, you're time slicing, and that makes things much worse because you can't get that momentum and that flow going. So really, it's more like you've got basically at most 2 weeks, and that's usually spread across multiple assignments, right? So you can't build large systems. You can't build any size systems. So there's no way we can give you feedback on how you do that. And then everyone's worried about grades, right? And often what happens when I grade this ruthlessly, the students are like, they come to me and say, tell me, is this assignment, second assignment is like, there's a whole long, some offices, just grade my assignment now, tell me what to do to correct it so I get a better grade, right? It's like, no, the goal is, we talk about things, we do this, this, and this, and this, right? And then you apply it, right? And then we see how you do. So it's 1%. So don't panic. You can panic after the second assignment. Any other questions? So I want to, we were talking about sort of general things, so it's OO development. I want to start talking about design patterns today. And hopefully we'll talk about assignment 1 on Thursday, depends on how much time I get to spend grading. Usually to grade this assignment, it takes me a good 10 hours. So I have to go through it and I have to make comments and I have to write the comments up, and so we'll see. So I want to start talking about design patterns. So what we'll do today is talk about sort of some background design patterns. And then I want to start looking at the observer pattern, in part because it's a very common pattern. I expect most of you have come across it in some form or another. And it's taken on a big role in a lot of new frameworks that are coming out. So interesting to see that. So let me So this whole idea of patterns started with an architect, Christopher Alexander. He's a architect faculty at UC Berkeley, and by architect I mean building buildings and houses and that sort of architect, not a software architect. And his whole idea was, we build structures for people to live in and work in, right? And people have an idea what types of things they want to do, but they don't have any idea how that relates to the architecture, right? They don't know how to, they say, I like a big kitchen, or I like this, or I like it, but they don't have any way of saying, to go to the architect and say, here's the types of things I do and want. And so he came with the idea of patterns, and so then he could what what people do, right? And then he actually has a big thick book on rice paper, so it's like this thick, and the very thin rice paper. So it's a really long book, and it's just a catalog of different types of patterns dealing with buildings and what people do in buildings and how they want to interact with them. And so in 1977, he published this book, and then Kent Beck and Ward Cunningham were, trying to figure things out, and they came across his work, and they go, this is a great idea. We need software design. We need software patterns. So at one point, Christopher Alexander gets this phone call from some program manager running a conference on object-oriented programming and said, "We want you to be a keynote speaker." And the guy goes like, "What? I studied architecture. I don't know about software." And, "Oh no, you're famous in our area." And so, here's one of his patterns. And we've all done this, right? You go someplace to wait. You go to a dentist, a doctor, the airport, right? And you have to wait until it's your turn to go to the doctor or the dentist, or until your plane can get on the plane. And so you're like stuck there, right? So what do? It's a very common thing that happens. And yeah, I mean, it's like the classic solution is there's some dreary room, and you go to the dentist or doctor, a bunch of 2-year-old magazines that no one's interested in, and people are, well, in 1977 they started each other. Now you start your phone, but still, I mean, you're just sitting there, just like doing something on your phone. There's nothing else to do, right? Um, and that's the problem, right? Is how do you do something useful or entertaining, but still be ready when, right? So yeah, it's just so those patterns, yeah. Let's combine the two areas together, right? So the example is in a pediatrics clinic for kids, right? Have a smaller playground there, so the kids can be doing something instead of just squirming, and but yet have it very, right there, so that when it's time to when they go to the doctor, it's like, okay, you just grab the kid and bring him into the doctor, right? Um, and other people, I mean, they just want to, maybe read a newspaper or do something private, just be quiet, right? So give them some, you know, have a smaller garden, or you look at I mean, even at the airport, right? Just having a big window so you can see the planes, do something, right? Um, so this is the type of patterns that right? This whole book is about. So then people could read it and then figure out how help him design buildings for them. I mean, his ultimate goal was to be able to people read the book and then they could pick the patterns they want, and that basically essentially designed the building of the home. Um, right? So there's a pattern that comes up in teaching. Went to a conference and they had this educators pattern symposium, and this is one of the classic ones where the problem is, um, you've got you got two concepts that are related, um, and you really can't understand A until you understand B, but you can't understand B until you fully understand A. So how do you deal with that, right? Um, so we got this. So you try and explain A right away, and then but they can't understand, but they don't understand B. Um, and so then it's like, okay, try, do this sort of, you start with A a little bit, and then B, and go back, but you make sure that your explanations are correct, right? You're not trying to simplify to the fact at the point where they're not correct. Okay, and you just go back and forth, and they slowly build up this knowledge, right? So that's just a type of pattern that people found in teaching. Um, Now, in our design patterns, the classic design patterns book, um, which um, is known in the industry as a Gang of Four book or GOF. Um, Most of you are too young to understand the reference to the Gang of Four. Um, During the Chinese Revolution in the 60s, there was four leaders that ran the whole thing, and so they were called the Gang of Four. And I don't see any. We don't have many Chinese students, and then our design pattern book is written by four authors, and for some reason they decided to call them a Gang of Four, and so often you see the GOF book, right? GOF. Um, they've got They apply two principles over and over again, and so you're going to see these applied in almost every pattern. Um, One is program to interface, not an implementation. Um, and that gives us flexibility because, well, if you program to interface, we can change the underlying implementation without things changing. Um, so example I use to try and illustrate this is in Java, there is this whole collection hierarchy, right? Um, and if I, create a new collection, XXX, it could be a set, a list, any sort of hash set, tree set, array list, linked list, vector, right? Um, and I declare a student to be type collection. That means later on, if I decide to use a vector instead of array list or a hash set instead of array list, um, I'm still good because it's just a collection, right? All the code that uses students just knows what is a collection. And so I've got the flexibility of changing or adding a new type, right? Um, and so we can change our mind on what type we want to use. It means that we can add a new type later and then assign it to students, right? Now we talked a while back what are the benefits of OO, and one is it's easier to modify programs. And this is one of the ideas that, if I program to interface, and now I create a new subclass of that interface or implement interface, I can now basically inject it in my program and not worry about things. But as soon as instead of saying collection, I say vector, or I say array list, right? Now the code that uses students is hard coded to that type. So we're going to see this over and over again where they are going to use program interface. Now, if you program in Ruby or Python and sort of JavaScript, but JavaScript's so weird that in languages like that, right, they like to talk about duck typing where we don't declare the type, right? It's just that as long as they have the methods that you're using on those objects, you're fine, right? You can always substitute whatever you want as long as they have those methods that you're using. Um, The second design principle is favor composition over inheritance. Inheritance is static, right? It's a compile time feature. Once you compile your program, that's it. You're stuck, right? Actually, it's even before that. When you write your code, right? In most languages, in Java, class foo subclass X, right? There's your inheritance. You're stuck. You can't change it, right? Composition, when I've got an object as a field, I can always change that field, right? So we get runtime flexibility as opposed to hard coding our structure when we start writing the code. So here, B extends A, and right, and this is as soon as I write that, right, I fix inheritance. We're stuck. We can't change it. Now, there are some languages where you can change a class's parent class at the runtime, but that's pretty rare. It's also a bit dangerous because if you change it to the wrong parent, it can blow up on you because you inherited methods in the fields and it becomes interesting. By composition, right, we have some sort of field in B, and it's of type A, right? And now on an object of B, I can just, right, call that operation on A to have it done. Which means later on, if I subclass A, I can substitute what that field is in B. And again, we will see many examples of this as we go through the various patterns. Now, the first couple of chapters of the design pattern book are difficult to read at first. One of the chapters, sort of goes through and talks about sort of examples, and they talk about this pattern, that pattern, this pattern. Like, for me, it's like, oh wait, you're talking about 10 patterns here, and we don't know what they are yet. And so the first time I read, it's like, you feel like, oh, I need to go read this pattern, and then I go back and read, and then another pattern. It's like all of a sudden you've read half the book just to read that, one section, that one chapter, because it just talks about 10 patterns, and what's that? What's that, right? And so some of those chapters you should wait until later, right, to go back to read, because then it's like, okay, I know, yeah, now I see how they're using this, what's going on. But now in one section there is, he talks about, oh, here are the patterns that help us change software in this way, right? So when you have algorithmic dependencies, you want to be able to change. You want to change which algorithm we use. The build iterator strategy. We need to be able to change classes. Okay. Dependency on specific operations. Dependency on hardware and software platforms. Tight coupling. I'm going to reduce tight coupling. So there's the different types of things we may want to change, we want change to occur, and they list various patterns which might apply. So this list, I don't expect this to mean much for you right now, because like, oh, what are these patterns? What do they mean? But at some point, then it becomes, oh, I've got this problem. I want I want to get rid of hardware dependencies. What do I do? Oh, okay, maybe I should look at the abstract factory and the bridge. So there's, if there's one thing you're going to remember, right, from this course, you want to remember that list. What you want to remember is that list exists and where it is and which page of that book, so you can actually, a year from now, you can, oh, I got this problem. Let's see which patterns it might occur. And I'm just repeating this, right, because I want you to keep these in the back of your head and see how they apply when we look at the patterns, right? Right. If our classes are huge, our methods are huge, that we're not going to be able to reuse those places. It's not going to be easy to replace them because the larger they get, the more specific they get to that particular situation. Keep different things that change, rates of change in different locations. And sort of this final test is if I can replace objects, easily, then that's a sign that we've got a good. So again, we want to keep these in mind as we go through the patterns and see if they help us do these things. It's sort of a check, right? And can we move objects around? New context. So I want to talk about the observer pattern. Pattern books that talk about patterns usually have a format to talk about the pattern. It's sort of like a catalog. So design pattern books are sort of hard to read because it's not like you can start and it flows through. It's not a novel. It's like reading a Sears catalog or going on Amazon and looking for things. You just bounce around and so basically observer pattern is I have an object, and when that object changes, a bunch of other things need to be notified that it changes and they do something, right? And we want them to be updated automatically. So the structure is pretty simple. So I have some sort of subject, and there's a bunch of observers. And when we call a method on a subject changes its state, then we just want to send a message to all observers saying I've changed, right? Now, how that's done is pretty simple. It means the subject just has a list of observers, right? And then when it changes, it just goes through the list and sends a method to all observers, and that's it, right? And so there's, how it works is, I call some method on the subject which modifies the state, and then it does whatever work it does to modify the state. Then it has to basically go through all this list of all observers and call some method on it, usually update or something similar. And then the observers need to know, okay, what changed, right? Tell me what changed, or give me the information I worry about, and then I'll do whatever I need to do. And then you go through and call next one, call next one, call next one, right? So basically, there's a loop inside the subject. There's for A and my observers, you know, call update on each one of them. It also means this is done sequentially, right? So if that observer takes a long time to process that request, right, then we wait. This guy doesn't have to wait until A is done. And then sort of the class diagram. So I have some sort of subject, right? And when it's italics, it means it's like a interface or an abstract class. And so we define various methods. I need a way of adding an observer and removing an observer and a way of calling all observers, right? And then we want an interface for the observer. Why? Because we don't want the subject to have to know all the concrete types, right? We don't want the subject to know, who is listening to it. It's an interface, right? And that allows us to program the interface. Why? Because now any object that satisfies the observer interface, I can add to the subject. We don't care about its actual concrete type because the subject only needs to know that I can call update, right? And so we're free to make the observers any type we want. Now, usually the concrete observer needs to know about the concrete subject because, okay, I need this type of information from you so I can display it or do whatever I'm supposed to do. But the subject doesn't know the concrete type of the observers. That's it. Yeah. Yeah. That's it. And it actually doesn't even need to be in the concrete subject, right? Depending on what language you're in, you might be able to do it in this, make subject a abstract class and implement the for loop there, right? And so that your subject abstract class could define attach, observer, detach, and notify. And then your concrete subject just inherits all that. Is this the pattern that would apply to most UI models? Yeah, so the question is this a pattern that we see in the interfaces? Yeah, it's a modified version of it, right? What's that? No, we'll see it in a few slides. Mm-hmm. That's a very good question. The question is, why not just, when I call update, why not pass the object itself or some information about the object, right? So there are a couple things which are important to understand about patterns.